Honors Algebra. Mr. Lawrence here with your flipped lesson for Tuesday, February 21st. Welcome back from the long weekend. I hope you guys had a good day at school today. I know that at the time of recording this, I could say I had a good day. All right, just a quick reminder, some of you owe me some stuff because you were absent. Please be getting that done. If you need to talk to me about when you're going to do it, just come talk to me, and we will set up a timetable to get you caught up. All right, as you know, we have started working with the big F word, and the big F word is pretty involved because there are many different types of the big F word factoring. We've learned how to GCF so far, and remember that GCF is the first type of factoring you should always try. All right, but now we're going to learn two new types today. We're going to learn a pattern called the difference. And right away, your brain should be going, difference means subtraction. Difference of perfect squares. And then we're going to learn about perfect square trinomials. Okay. Now, we're going to develop these patterns by foiling. Okay. So some of you might remember that last week, before I went, we had problems that looked like this, or we might have had x plus 5 times a quantity of x minus 5. Go ahead and FOIL that for me. Hopefully you're getting really quick at it. If you're still watching at this point, I assume you're done foiling, and I'm going to get x squared minus 25, right? Because the outers and inners are going to cancel out. I'm going to get a 5x and a negative 5x, and they'll cancel each other out, right? That also works when I have something like this, say 3x plus 7 times the quantity of 3x minus 7, right? If you're good at foiling, if you know your multiplication factors, you know your outers and inners are going to cancel, when you FOIL this guy, you're going to get 9x squared minus 49. Okay? These answers in black here are the difference of perfect squares. They're the difference of perfect squares. Did I say they're the difference of perfect squares? This term is a perfect square. The second term is a perfect square. And it's subtraction. Perfect square, subtraction. So to factor according to the difference of perfect squares, let me write that again. The difference of perfect squares. All right, if I have two perfect squares, one being subtracted from the other, they will factor very easily. They will factor, these black ones would turn into the red ones. Yeah, they're going to look just like that. So let's see how that works in action. Well, let's say let's do a perfect square. Let's do 64x squared. And I'm going to put a perfect square there that isn't a factor of 64, because if I do that, I got a GCF, and I don't want a GCF right now. Nothing wrong with GCFing. It's one of my most favorite types of the big F word, but for this example, I don't want it. So I'm going to pick, say, 1. Okay. Now I'm going to look, and I'm going to say, perfect square? Absolutely. Perfect square? You got it. Is it subtraction? It is. So all I need now is I need the square root of 1, and I need the square root of 64x squared. Well, this is 8x. This is 1. This is going to factor just like this. 8x plus 1 times the quantity of 8x minus 1. See how simple that is? That's the difference of perfect squares. It works whenever there is a perfect square subtracted from a perfect square. For example, how about this one? How about, let's see, x squared minus 36. Is the first term a perfect square? You betcha. Square root would be x. Is the second term a perfect square? You betcha. The square root would be 6. Is it subtraction? Don't forget to check that. X plus 6 as a quantity times x minus 6 as a quantity. There you go. You just factored according to the difference of perfect square pattern. Now I'm going to try to trick you here. Let's say you had this one. 9x squared plus 25. Perfect square? Yes, it is. Square root of it would be 3x. Perfect square? Yep, be 5. Subtraction? No, it is not subtraction. This one cannot factor. Right now, you will tell me that this one is prime. There is no pattern for solving the sum of perfect squares. So that would be a prime one. We can't factor it. Okay, we'll be able to solve it later on when we learn the quadratic formula, but that's still a little bit of ways away. All right, so this would be prime. Okay, now there's one more situation I want to look at really quick. And this situation would be when we have something like this. Let's say we have, let's go with 50 x to the 4th minus 32 x squared. Well, the first type of factoring you should always try would be GCF, right? So hopefully you're realizing, oh, for the GCF, I'm going to pull out, let's see, I think a 2x squared is my GCF. So I'm going to factor out a 2x squared, and I'll be left with 25x squared minus 16, right? I'm not done, though, because look inside here. Look at this. Perfect square, you betcha, square root would be 5x. Perfect square, yep, 4. Subtraction, ding, 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 ding. All right, this will factor as 2x squared. I can't lose the GCF that I pulled out, times the quantity of 5x plus 4, times the quantity of 5x minus 4. And there you go. You just factored by the GCF. All right. Now, let's go up here, and let me see if I can cover up some of this so it's not in our way. There we go. Perfect square trinomials. I'm getting some lag going on here. All right. Perfect square trinomials. Remember, when we have ones that look like this, x plus 3 times quantity of x plus 3. On those, the outers and inners don't cancel out. If I FOIL that, I get x squared. I know it's going to end in a 9. I'm going to get a 3x and a 3x. I'm going to get a 6x. Right? Okay. Let's try another one here. Let's say I have 2x plus 5 quantity squared. Well, I'm going to get a 4x squared, right? It's going to end in 25. My outers will get me a 10x. My inners will get me a 10x. This will be plus 20x, right? Okay, so now, here's how this works. You may not realize this, but you see this guy? He's a perfect square again, isn't he? Perfect square. So is 25. Perfect square. All right. The square root is 5 over here. The square root over here is 2x. What is 2x times 5? 10x. Doubled? 20x. If that's the case, it factors as a perfect square trinomial. The square root plus or minus the other square root. How do you know? This sign right here. Let's check. Let's try a couple. Get rid of that shade. Let's say we had, hold on one second. Okay, let's take a look at this example. It's a trinomial. Is the first term a perfect square? Sure it is. And the square root of that would be 4x, right? Is the last term a perfect square? It sure is, 3. What's 3 times 4x? 12x. Double it, 24. Look at that, it matches 24x. So here's how this factors. The quantity of 4x minus 3 times the quantity of 4x minus 3. So I use the square roots in each quantity, but this sign tells me which one to use. See how simple that is? Let's try another one. Okay, on this one, first term, it's a trinomial. First term is a perfect square. Square root would be 6x. Perfect square? Yep. Now, is the middle term twice the product of 6x and 7? Well, 6x times 7 would be 42x, right? Double that would get 84x. And sure enough, there's an 84x there. I take this sign and I put them there. And then have a second quantity that's identical to it. Now some of you are thinking, Mr. Lawrence, could I have just written it this way? Gold star to those of you thinking that. Exactly. So, tell you what, let's put up a couple problems and you identify whether they're perfect square trinomials, difference of perfect squares, neither, and then go ahead and factor the ones that are. So hold on a second. Okay, take a look at these 4 examples here. Your job is to decide, are they differences of perfect squares, perfect square trinomials, or neither? Okay, the neither ones we won't factor yet. We're going to assume we don't know how to, or that they can't be factored. And then the other ones you need to factor. So go ahead and pause the video and you decide what they are. When you've unpaused, I will assume that you want to know the correct answers. All right, if you're still watching at this point, this first one does fit the difference of perfect squares. That's the difference of perfect squares. It's important not to forget that. Okay, I have a perfect square minus a perfect square. It'll factor as 5x. Where'd I get 5x from? It's the square root of 25x squared. Plus 3, where'd I get 3 from? It's the square root of 9. And then a 5x minus 3. That one is factored completely. The second one, and of course, go ahead and pause at any time if you don't want to hear the solution yet. The second one, I have a perfect square plus a perfect square. This one is prime. It is neither of them, and there is no pattern to factor that. Okay, let's look at the third one. It is a trinomial. This is a perfect square. Its square root is x. This is a perfect square. Its square root is 5. If I multiply those two together, I get 5x, and then I double it, I get 10x. Ooh, that doesn't match. It has to be the product of the square roots doubled, and that's only the product of the square roots. So this one is neither. It may factor, but it won't factor by any of these patterns. It might factor by a pattern we might learn later. And actually, it won't factor. We'll have to use the quadratic formula, but that'll be chapter 10. All right, let's go to this fourth one. And again, pause if you're not ready to see the solution. I got a trinomial. It's a perfect square, x, perfect square, 4. 4 times x is 4x, and if I double that, I get 8x. Ooh, look, I've got a match. So this is a perfect square trinomial. I'll do x minus 4 times quantity of x minus 4. Or more simply said, for those of you that are lazy like me, you could write that. All right, that's the lesson for today. We'll get some practice for this. Now, third period kids, you aren't going to be having my class the next couple days. You need to keep up on the videos, and I will be giving you worksheets to practice. All right, Mr. Lawrence signing off.